Hi guys. Okay, SOHCAHTOA was all about right triangles and the trigonometry using hypotenuse, opposite, and adjacent. We are shifting our focus now to non-right triangles. So sine law is used for non-right triangles, and that means they do not have a 90-degree angle in them. Okay? One of the things that's most important is that a hypotenuse only exists if you have a right angle. So for example, if you have a right angle triangle, then the hypotenuse is the side across from that. Without a right angle, there is no hypotenuse. And if there's no hypotenuse, we can't possibly use those formulas from earlier with opposite and hypotenuse, adjacent and hypotenuse, and so on. So we need new processes to be able to solve non-right triangles, and that is what sine law is used for. So when you're labeling triangles for sine law, you always label angles and sides are across from one another. So what that means, and we're going to do some examples right below here, but if this is triangle ABC, then side A is actually directly across from angle A, and we call it lowercase a. Side B would be across from angle B, and we call it lowercase b. And then if this is angle capital C, then side C is across from it at lower c. And that's the way that triangles are always labeled for the remainder of trig. So sides are labeled with small letters, and angles are labeled with capital letters. So anytime you see a capital, you know you're dealing with an angle, and anytime you see a lowercase, you know you're dealing with a side. And then let's just quickly go through these examples. If this is capital angle P, then lowercase p is across from it. Capital angle Q is here, meaning lower q is the side length across. And capital angle R pairs up with the side length across from it as lower r. These are the side lengths given, x, y, and z. If this is lowercase x, then capital X is over here, across from it. Capital Y would be directly across from lowercase y, and capital Z would be up here, across from lowercase z. And this triangle, if this is capital angle D, then lowercase side D would be this one across from it, so it's always across. This is side A, meaning capital angle A is over here. And if this is side C in the triangle, capital C is over here. So it doesn't matter what the triangle is named, it just matters that the sides across from the angle are the lower version of the capital letters. Okay, like I said before, the primary trig ratios, SOHCAHTOA, can only be used if there's a 90-degree angle. So in these questions today, there are no 90-degree angles. And we have a new formula, and it's called the sine law. That's a lowercase c. So small a over sine of capital A equals lowercase b over the sine of b equals the lowercase c over the sine of c. And that formula can also be completely reversed where the signs are on top and the lower cases are on the bottom, which is the side lengths. Now, there are reasons as to why we have two formulas. It's easier to use the first formula if you're solving for a side length. So I'm going to put that a different color. The reason it's easier to do that is because if you're solving for lowercase a, b, or c, it's easier if that's in the numerator, so if it's on top. This version of the formula, the second one, is easier to solve if the angles is what you want to know. So if you're solving for an angle, it's easier if the angles are on top. So that's my recommendation as to which formula to use. If you want to know a side length, put side lengths on top. if you want to know an angle, put angles on top. All right, when can sine law be used? There's a couple times when you would use sine law, but the most important thing is when you know a complete pair. And a complete pair is if you have, for example, capital A and lowercase a, or if you have capital B and lowercase b, or if you have capital C and lowercase c. So if you know a full pair, the angle and the side across, then you can use sine law. So let's look at this first example. We know lowercase d is 54 because it's across from 34. So we actually have a complete pair. We know both capital D and lowercase d, and we know capital E, and that's going to help us solve for lowercase e. Now the formula is in terms of A, B, and C, but it doesn't really matter what letters you use as long as they pair up. So we can use D, E, and F, and it's going to work just the same. So let's do D over the sine of capital D. We're going to pair those two up. That's the formula. And because we know capital E, we're going to do E over the sine of capital E. Now the formula has all three sides of the triangle in it. This one, and this one. But you actually only use two at a time. So we're not going to do F yet because we actually don't know anything about F just yet. We're going to solve just D and E first. Let's fill in what we know. So the side length D is 54 over the sine of angle D, which is 34. Side E is what we don't know. It's going to remain lowercase e. And that's going to be divided by the sine of the angle E, which is 50 degrees. It gets really important to use your degree symbols here because as we start to solve, it can be confusing as to which one is an angle and which one is a side length. So notice I put little dots to represent the degrees, just so I can keep straight what goes with what. All we want to do now is get E by itself, and just like we did in the previous lessons, to get rid of dividing by sine 50, we bring it up and we multiply. So you end up with 54 times the sine of 50, and it's still divided by the sine of 34, and that gets E by itself. You're basically multiplying both sides by sine 50, and it cancels it here, and it brings it up and over. So on your calculator, you can do 54 times the sine of 50 degrees, and you divide by the sine of 34 degrees. And you get 73.975. We're going to round that to a 74.0 perfectly because the 7 would round the 9 up, which would round it to 74. So we just found lowercase e. Okay, from here, because it asks us to solve for everything, we now want to know a little bit about f. So we need to know angle f if we want to solve for side f. The easiest way to find angle f, keep in mind triangles always add to 180 inside, we can just subtract off the 34 and the 50, and that's going to give us angle f, which is 96 degrees. Okay, I'll do this last part of the question in red. We now know this is 96. We still knew our pair of capital D and lowercase d. And we are going to use that pair to solve for lowercase f. So I'm going to stick with the pair I was given to begin with, which is D. And we're going to put that now with f because we want to solve for the final side length that we don't know. So this left side is going to be the same as it was in our first question there. Lowercase f is the last thing we need to solve, and we know that it pairs across with sine 96. We can just get f by itself by bringing sine 96 up and over. So 54 times the sine of 96 divided by the sine of 34, and f is 96.0 meters. E was meters as well because we had done a side length. And capital F was a degree. And there's the whole triangle solved. All right, let's try another one. This triangle's not drawn for you, but we can just draw any random triangle, DST. I'll do it in black. And angle D is 47 degrees. Notice I didn't draw a right triangle because we know that if it's not given as a right, we can't assume that there's a right angle. So I just drew any regular acute triangle. And it doesn't have to be to scale. We don't really know what side lengths are going to be what until we solve it, so we can't really draw it to scale anyway. Lowercase d is 78. That's always going to be across from the capital angle. And it gives us lowercase s. Lowercase s would be across from capital S, so that's 106. And our goal is to find angle S. So our goal is this one. We have a pair again. Our pair is, once again, capital and lowercase d. And we're going to use the 106, which is our S, to find capital S. Because we're solving for an angle, like I said up here, it's easier if your angles are on top when you're solving for them. So make sure that you put angles on top this time. So we will do the sine of 47 degrees, and it pairs across with 78 on the bottom. So notice I didn't even write the formula because I just know that these are going to pair across from each other, so writing out the formula is not always necessary. Sine of S pairs across with 106. So I'm just pairing this and pairing this. All I have to do now is multiply by 106 because if something's being divided by 106, we cancel it by multiplying. In this case, a whole number of 106 comes in front of sine 47. So we actually write it as 106 times the sine of 47 divided by 78. The reason we do that is because we don't want the calculator to accidentally do the sine of 47 and 106 as an entire angle. We want to make sure we multiply 106 by the sine of 47. And we divide by 78. You're going to get a long decimal, 0.99, and it keeps on going. Those numbers are going to be important. If you round it off, you're going to get really, really different answers. So we have to keep all that in the calculator. And then remember, we're solving for an angle, just like we did in SOHCAHTOA. To solve an angle, you need the inverse button on the calculator. So on that 0.99 that's sitting on your calculator, 0.993890927, you're just going to hit sine inverse and hit equals. If your calculator won't let you do that, then you may have to write down all these numbers and type it back in. Okay? So capital S is the sine inverse of that long number, that whole thing. So on my calculator, I can just hit second function sine inverse equals and it'll work. If you have a Casio calculator, if you hit second function sine inverse and you hit this button, answer, it will give you the sine inverse of this last answer. Okay? You can email me about that if you have any questions about that, or you can Google it. If you Google a Casio calculator, it should, if you look up YouTube, it should tell you how to bring up the last answer on the Casio version. Okay, S is 84 degrees. And this question did not ask us to find anything other than S, so this question's done. And last example, find the perimeter of the Bermuda Triangle. So we have 3 points on the Bermuda Triangle, and one distance is 1,800 kilometers. We want to find the perimeter. To find the perimeter, we're going to make sure that we have all the side lengths. So right now we look at this and we don't appear to have a complete pair. Remember that if you know 2 angles in the triangle, we can find the third angle. So we're going to solve for B, and then we will have a complete pair. So it didn't appear like there's a complete pair, but there actually is with a quick calculation. 180 minus 50 minus 74 is a 56-degree angle. And now we have capital B and lowercase b. We can solve for M or S first, it doesn't matter. Let's go with M. So I want to pair up, since I'm solving lowercase, I want lowercases on top. I'm going to pair up lowercase b's with capital B, and we will choose to do M first. So that time I did write the formula first. 1,800 is across from the sine of 56. Lowercase m is across from the sine of 50. So once again, this pairs and this pairs up. And to get lowercase m by itself, I just bring sine 50 up. And that leaves m alone. So 1,800 times the sine of 50 divided by the sine of 56. $1,663.2 equals m. Sorry, I don't know why it keeps wanting to jump to the top, but we are almost done. Okay, we just have to solve for lowercase s now. I'll do that in a different color. Let's do s over the sine of 74, because those two together. And since b was the original one that we knew to begin with, we're going to stick with lowercase b over the sine of capital B. It's always good to stick with the pair you knew from the beginning, because just in case you made some sort of mistake on the other question, you don't want to use that 1663 if you don't have to. Okay, so we're sticking with the 1,800 over the sine of 56. This time I have my unknown on the left side. I did want to do it that way because it doesn't make a difference. It really doesn't matter where your unknown is as long as it's in the numerator. So I wanted to make sure that we did one where it's just flipped. The sine 74 still comes up and multiplies. So 1,800 times the sine of 74 divided by the sine of 56. $1,800 sine 74 divided by sine 56 becomes 2,087.1. So we have all 3 sides of our Bermuda Triangle now. Remember that the question was to actually find the perimeter of the triangle. So we're not quite done yet, because the perimeter would be the total distance. We were given the 1800. Don't forget to add that one in still. We found side length 2 to be 1663.2, and we found side length 3 to be 2087.1. Basically, add that all together. Sorry, there wasn't enough room for me to write it side by side, so I kind of wrote it up on top of each other. Maybe the plus sign should have been here, like elementary school. But when we add that all together, the most important thing is that your final answer is 5,550 kilometers. And it asked us for the nearest kilometer, so I just took off the 0.3. That is our perimeter of our Bermuda Triangle. All right, there is literally one lesson left in the course after this. So I will post that last lesson next week. You'll have a quiz on trig, and we are done the course. We got through everything that was the most important for grade 11, and you'll have a culminating posted next week too that you'll have about 10 or 12 days to do. Okay? Enjoy your weekend, guys, and catch up on some homework if you haven't done some lately. Okay, bye.